In this example, we've got a CD here, and the CD goes on a spindle. This is like when you buy a DVD in the store, or CD, the consumer packaging. Plastic base down here. And so what we're looking at is this CD, this pylon or tube is a 1/2 inch in diameter roughly. And I've got a CD that fits over it, and the ID of the CD is 0.58 minimum. So the manufacturers guaranteed us that that within their tolerance scheme we will not see a disc smaller than 0.580 inches. So this thing is consumer packaging. It's going to hold a whole bunch of CDs, and so we have to come up with what is the correct tolerance for this. What's the correct tolerance? Now, I've got a couple of questions about how this is going to be used. The first one is this critical? And kind of misspelled critical there. Not doing too good this morning with the tablet. But forget critical. What happens? What's the downside if there's a failure with this design? There's no loss of human life. It's how critical can it be? A plastic disc fits on a spindle. The environment this is going to be in, that's my next question. Is it going to be subjected to heat, vibration, high loads? Not really. It's consumer packaging. The maximum load that we're going to see, what do these things weigh? A few ounces, something like that. So the worst thing that could happen is CD falls off on the floor or something like that. Now what we're going to do, so what is the correct tolerance here? I've got plus or minus 1/8 of an inch here. We could go plus or minus 60 thousandths. This plus or minus 1/8 of an inch, that's going to be our cheapest tolerance. That's 125 thousandths. That's a wide open tolerance. And we're going to range from cheap to expensive. Down here, this last tolerance, the 5 thousandths of an inch, that's going to cost us a lot of money. If we want that type of tolerance, someone can make it for us. It's going to take special tooling. It might take special processes. We're not going to be able to make the production rate that we make. So these things range from cheap, a cheap tolerance, a big wide open tolerance, to an expensive tolerance. And so this 60 and 30 thousandths, these are going to be the in-between tolerances for this. So if I apply this 1/8 inch tolerance, that's going to make, if I go plus 1/8 inch, that's going to give me 0.5 inches plus 125 is going to be 625. And so if I use a plus or minus 1/8 of an inch, I can end up with a CD that's too big. 625 versus 0.58. That's what the manufacturer said, the minimum hole size. So that will not fit. So what I've got to do is I've got to pick one of these other tolerances. I picked 60 thousandths. It's the next largest tolerance, but it will fit. 5 inches 060 is less than 0.580. So that's my good tolerance. It's going to be my cheapest tolerance. And when I choose the cheapest tolerance, it's going to save money. It's going to make me a better engineer. And why do we want to waste money? There's no value added to making this CD pin a super high tolerance. So 060 is what we want to use here, and that's the answer to our question. My rationale is it was non-critical, and it's in a clean environment, so I picked my 60 thousandths. So if I have to be asked to substantiate it, that's why I chose it.